And hello, welcome everyone to this video. This video is dwsim. Now I have not used dwsim in like 4 years. I never thought I'd use a chemical process simulator again, but my project might need this. So yeah, my project kind of takes different turns, so I end up needing to use this. So yeah, dwsim is free and open source chemical process simulator. It is a cross-platform, thankfully, cross-platform simulator. However, its native platform is in Windows. Okay, most of its code is written in .NET. It looks like it's .NET, or at least it is developed on Windows, and it has a lot of things. Let me see. Yeah, source code is here on GitHub. But I don't see very clear compile instructions on any other platform other than Windows, at least for the GitHub one. I'm pretty sure you can do it on Linux if you figure it out. I have not figured it out yet, but yeah, this is what dwsim is. It is open source, but it's very Windows dependent. As you can see, its operating system is based on the .NET framework. For Linux, it is based on Mono 6.8 or newer, at least for the 2022 version. Okay, Mono is actually the open source version of .NET. Okay, if I do Mono Linux is a free and open source .NET framework. Okay, free and open source .NET framework. And .NET Framework is exclusively for Windows. Okay, it is developed by Microsoft, so Mono is the free version. So most of dwsim, or if not all of it, is done in .NET. Alright, so you will find it most compatible with Windows. Okay, Linux ports are kind of limited. As you can see, the only Linux options here are the Debian edition, which means things like Ubuntu, Pop OS, any Debian based distribution, Linux Mint, those would work over there. However, for every other Linux distribution, the official download is a wine prefix. Okay, it's a 7z compressed wine prefix. So I mean, the Windows stuff is there. You can run it on any Linux distro, but it's essentially adapting Windows stuff for Linux. So you will have to use Wine. Now I've not figured it out. I've not figured out how to do it yet, but if I do find time to do it, yeah, then I will. So yeah, this is the introduction and installation. At least for Windows. Okay, so Windows install is pretty straightforward. Just download it, follow instructions. You won't go wrong there, and I chose to install everything that is on the checkboxes, so that's where we are. Okay, this is dwsim. As I open it up, I install everything including the ChemSep libraries and whatever. So yeah, the graphics are much nicer than they were like 4 years ago. So rather, instead of saying 4 years ago, I'll say in 2018. They're much nicer than they are in 2018. There's even a pro version now. So let's see how far it has come. Very happy for Daniel Wagner. I think he's the developer of dwsim. Okay. See, yeah, Daniel Wagner. Okay, if I pronounce your name incorrectly, please let me know. Yeah, so that is his software. That's why it's called dwsim, Daniel Wagner Sim Simulator. Alright, so yeah, without further ado, let's start. Okay, so of course I'll link all of this in the description below. What dwsim is, where's the download site. No Linux installs just yet. I'm kind of it's been kind of a long week, so I'll go for the path of least resistance, and since I have Windows already, I'm just going to use Windows for the time being. Okay, so let's get started with the simulation. Okay, so you may or may not have used dwsim or HYSYS before or whatever. So these are chemical process simulators that can simulate stuff like an entire process flow loop, whether it's a steady state or dynamic kind of a thing. Okay. So yeah, you'll be when you start. Okay, let me close this. Okay, yeah. Okay, when you start the thing, you just click File, New Chemical Process Model on the top left hand corner. At least for the 2022 version. I recorded this video in February 2022. Okay, so you just click next to continue. So don't worry. So the first thing they'll ask you is what kind of compounds you expect to use in this simulation. Okay, for me, I expect to use therminol, which is a mixture of biphenyl. Okay, biphenyl and diphenyl oxide. Okay. Okay, they don't have everything here. But yeah, if you look online, therminol, dwsim, therminol VP1, yeah, the first step is to choose the stuff, and then you need to find the thermodynamic model that fits that. The one that fits that most is the cool properties incompressible properties package. So okay, and you can configure it to use the fluid of your choice. It says this will work independently of the compound you've selected for the simulation. So what he's saying here is that the compounds that we selected just now, even if it's not the full therminol, well, the closest thing I got is biphenyl because that's one of the components of therminol. Okay, so yeah, since that is the closest thing, I just selected that, but any fluid will be okay. But for this video, I just select that, and I use the coolprop incompressible fluids thing, and then you have to add, and then of course you have to configure it to use therminol VP1. To do that, you go to the three dots over here, and then you look at the model parameters. The fluid, you have a lot of fluids to select from the drop down menu. Okay, you can just go down all the way to TVP1 or therminol VP1 and just click that, and that will be okay. The rest of it I'll just leave it as a default for now, and I'll just click next. Okay, system of units, there are lots of things you can do. For example, SI literally uses all the SI units here, which is my preference. However, for my case, I like to have my temperature in degrees C. And for example, if you want your mass flow rate in kg per hour, you can do that as well. So if you want to edit this, the best way to do it is to clone the SI system of units. So you see this button here, clone. Just click that, and then you see this system called SI10, or you can create one like that. Okay, therminol simulation units. Okay, then that's not really accurate. Just custom my favorite units. Okay, so what are my favorite units? I use degree C. Pressure is well, what should I use? Pascals, kilopascals. I think I'll leave it. Okay. Mass flow rate, I will like it in kg per hour, because you can use some of the other units as well, like pound per minute, pound per whatever. Molar flow rate, volumetric flow rate. These things I will just leave it as is. Specific enthalpy. Everything else I am leaving it as is. So I can call this my favorite units, and then I'll just click create and add. And then I'll just click finish, and my process simulation it starts. if you ever want to edit your simulation settings, just go to edit simulation settings, and you will be able to edit whatever you want. For example, what compounds you want to add in, what's the thermodynamic property package. You can even configure your cool properties again. Okay, under the thermodynamics tab, so there's a compound tab, thermodynamics tab. You can configure reactions as well, but I'm not going to use the reactions, at least for this video set or for my project. So this thing I'm kind of going to leave out until I need it, or unless I have time to talk about this. But yeah, okay, never mind. No promises that I'll do reactions, okay, or any of these things. Okay, so system of units you can edit, object properties, floating property tables. Okay, you can even check all these checkboxes that displays the temperature, units, mass flow, whatever. This will be quite useful. You can do the mass flow and temperature and pressure. This will be quite good if you want to check things out. Number formatting, it's really up to you. So yep, that's it. And then of course, if you want, you can just save everything as. I can put under my documents. I can put under YouTube, and I'll just make a dwsim folder. Okay, dwsim. Okay, so this will be compressed XML dwsim file, and I will just say it's YouTube demo 1. So my fluid of choice here is therminol, and I'm going to do some things. So let's get started with something very simple, a pump system. Just a pump system. Okay, so 1205. Okay. Again, I'm no expert at this. I'm learning this as things go. I have some experience doing Aspen HYSYS before, but I'm not that good. I have some videos on that as well, but well, yeah, it's not that fantastic. Okay. Okay, so here's my material stream. Pardon me, I did not really explain what's going on here. So to do material stream, okay, let's talk about our objective first. We want to simulate let's say a stream of therminol at low pressure, and then we want to kind of increase the pressure back up. So how do we do that? Because you have therminol flowing through a pipe, and going through the pipe, it will lose some pressure, and then you kind of want to add a pump to increase that pressure back up. Okay, so that's the standard flow for fluids. So it's going to be an isothermal case, and I don't want so much flow rate. That seems ridiculously crazy. Maybe I'll just put 0.04 or 0.05 kg per kg per hour. Okay. Hey, maybe. Okay, never mind. Maybe I like to change the units again. Okay, I don't like kg per hour. Yeah. Well, should I do kg per hour a second? Never mind. It's irrelevant. Let me just put 800 kg per hour. I'll leave it as is. And to change your settings, just press enter. Okay, so let me introduce you to the thing. So normally when you start, you'll be introduced to this screen. And to make a new material stream, let's say you want the therminol A, just drag the material stream on the screen, okay, and then delete it if you don't want it anymore. Okay, so if you want to edit the material stream, you just double click it, and then you'll be brought to this settings interface on the left. It's a lot of settings, can be pretty overwhelming. So let's go through the things one at a time. Okay, so again, remember, I want this material stream to go through a pipe, and then it will lose some pressure there, and then I want to increase the pressure again. Or rather, I put it through a pump first, and then make it go through a pipe so that you will lose some of the pressure. So I'll call this stream therminol stream inlet, okay, because it's going in. All right. Okay, so let's just go through the things we need to set now. Okay, the temperature is about 25 degrees C. Pressure is about 1 atmosphere. That's fair. Mass flow, I'll just set arbitrarily at 800 kg per hour. Okay, compound amounts. Yeah, you will need one compound. Where's the compound? Okay. Yeah, I will need a compound here. Let's do biphenyl again. Phenyl. Okay, so it will just this one is a 100% biphenyl. Okay, so this is under input data. Stream conditions, you will be able to edit the flow rate, the pressure, the temperature, whatever else. And of course, dwsim will calculate the enthalpy, entropy, whatever for you. Okay, compound amounts, I'll just leave it as biphenyl, but that doesn't really matter. Remember just now we are saying that Daniel was saying that, you know, you can configure it to use the fluid of your choice, and this will work independently of the compound you selected for the simulation. But you must take use at least one compound. All right, so okay, yeah, hold on, what am I doing? Okay, never mind. Yeah, and I think this guy, this Daniel is the same Daniel Wagner that we are talking about. He's from Brazil, I believe. So yeah, you can support him if you want. See, Daniel Wagner. Yeah, I don't know how to pronounce your last name, so sorry, but yeah, he's the developer, so he knows what best to use. Okay, so we will use this. We'll just use biphenyl as our material, but that doesn't really matter. The thermodynamic properties will belong to therminol VP1. Okay, so everything else, there's a results tab, annotations tab, dynamics, floating tables, all these I will not touch yet. Okay, what do I want to put this stream through? I want to put it through a pipe. So where do I find the pipe? So I can close this stream inlet. So under streams, there will be material stream and energy stream. So we won't deal with energy just yet. We'll just deal with mass. Okay, we'll go through to pressure changes. And what will we have under pressure changes? Okay, and this really nicely, you know, arranged for us. Orifice pipe, compressor, pipe segment, pump, expander or turbine, and a valve. So I wanted to go through a pump first because you need to increase its pressure before forcing it through a pipe, right? That makes sense. Okay, so this is a pump. Okay, this is a pump, and if you double click the pump, you will be you'll again come to this left hand side. You will be able to edit a lot of the properties of the pump. For example, the name. So we'll just call this my pump, okay, or therminol pump. Okay, what's the and over here, this is the general info. Under connections, you will be able to edit the inlet stream, outlet stream, and energy stream. So we want a stream of therminol going into the pump and a stream of therminol going out of the pump. So the inlet stream will be this therminol stream inlet. So you can actually go to pump, select from the drop down menu what's your inlet stream, and then it will just connect like that. Okay, very simple. If you want to disconnect it, just press this disconnect button. That's just to the right of this lightning button. This lightning button is called create and connect. The other thing in Portuguese, so yeah. So this is a create and connect button. This is a disconnect button. So if you want to disconnect, yeah, just click that disconnect button. Okay, so that's the terminal stream. So we just leave it as wait, why is it not changing the name? Terminal pump. Okay, so now it's changed. So remember to press enter or press enter every time you want to change things. So outlet stream, well, we have not made an outlet stream just yet for the terminal pump. We can just use the create and connect button, and then we'll have this MSTR02. MSTR stands for material stream, M for material, STR for stream. And then of course the statistics are wrong, especially if you look at the mass balance, 800 kg per hour in, 3600 kg per hour out. That doesn't make sense at all. But once you click the calculate button, you should be able to get the correct mass flow rate out. Okay, so that is the connections. One more thing you need to know is this energy stream. Okay, energy stream is how much energy do you need to put into this pump. Okay, so you can do a create and connect, and this energy stream ESTR will be just created. Okay, inlet connection, nothing is actually given. Outlet connection is the terminal pump here. Now, in case you're wondering where this 25 degrees C, 100,000 Pascal and 800 kg per hour, where is all this coming from? Okay, all this is here not by default. It's because I edited just now object properties, or under the simulation properties, I was able to tell dwsim to display all these things under the material streams. So if I'm not wrong, yeah, under object properties, the stream properties, material streams, you'll be able to display temperature, pressure, and mass flow. Of course, this is the default. This is what you'll see by default. But if you want to see these three very important quantities, you can just check the boxes here under object properties, under simulation settings, alternate S over here. Okay, so this is a very basic simulation. Okay, if you just click solve flow sheet or F5, everything will turn blue, which means it's solved, and you can see the what do you call it, flow rate here is automatically corrected. Okay, now you can see the inlet and outlet pressure are exactly the same, which is not what we want. So how do we deal with that? Okay, so the nuts and bolts of a pump is that, well, you need to change the way the pump is doing its calculations, because after all, this is just this pump here, underneath is just a block of code that calculates various properties based on the inputs you give it. So the output is definitely this pressure and this material stream, right? What's the input you need to give it? Well, you'll see all these inputs under calculation parameter. Of course, the terminal stream that you give it is also gives the pump an input, but the other things you need to set are over here under calculation parameters. You can select from a drop-down menu, okay, where you can see the pressure increase for this pump. You can set the outlet pressure, or you can change the power required for this pump. Okay, energy stream. Okay, so if you set energy stream to be the calculation mode, that means you need to give this energy stream some degree of power, and that will sort of, you know, calculate how many pascals of pressure you are giving to this fluid. Alright, then the other one is performance curves, which you can edit over here. Again, you'll be able to configure your curves here, your pump curves, if you want. Okay, I've not tried this out yet, but I know this thing exists, so I don't know how good this thing is, but just for simplicity's sake, you can just define a set increase in pressure or outlet pressure. Okay, the rest is power required and energy stream, which are two ways of saying the same thing. Okay, but yeah, one is that you edit this energy stream here directly. The other is that you edit this power required over here in kilowatts, and that will actually change the energy stream here. So both of these are physically the same thing if you talk about physics, but yeah, what I like to go for is pressure increase. So let's give this about 500 Pascal increase. Okay, if it's 500 Pascal increase, you just click that and you press enter, and then you save. And look at the outlet pressure, it is now 101,825 Pascal. 101,825 Pascals. Okay, so this is how you deal with pumps and, generally speaking, streams and energy streams. Okay, so it's a very long video. I don't want to hold you up anymore. Okay, I'm going very slowly because I know the first time I come back to look at dwsim, this is just an overwhelming amount of data and amount of information being thrown at you. So, and I haven't used it in a while, so I'm kind of rusty, but I'm making these videos as a reminder for myself. I hope it's helpful to you if you find it. Okay, but yeah, it's more a reminder for myself in case I forget how to use the code again. Okay, so that's all, and I'll see you next time.